Tucker,
about
what do you
I
need?
have to
I
retake.
gave you a pen.
Yeah, well, I lost it.
Are you?
I found one.
You think
Someone
pens
said
should
more
grow
about
on
it.
trees?
No.
Oh my
I
God.
dropped it and literally disappeared in the non
Can you watch
square.
it?
Man. All right.
Oh.
All right. So we're talking about angle bisectors. Now we know a couple things about angle bisectors. What do we know? What do you know about angle bisectors?
That it bisects the angle.
It bisects the angle, splits it in half. That's right. Sect as in cut, like sectum sempra, right? Harry Potter fans.
Never
and then-
watched Harry Potter.
No, good for you. And then bisect bi means two, right? So bisect means to cut into two pieces, not just two any pieces, but two equal pieces. I feel like that's left out a little bit in the Latin phrasing, but it cuts into two equal pieces. What else do we know about angle bisectors? Just had a quiz that included angle bisectors. What do you know about angle bisectors?
That it's the incenter.
On fire! All right. So when we go to angle bisectors and they intersect, they create the incenter. What do you know about the incenter?
It's the
The center of the circle inside the triangle.
Oh, Australia. All right. So
P minus.
circle inside the triangle, right? The incenter is the center of that circle, which means that if we go from the center, the incenter, right, and we go out to the sides of the triangle, making sure we hit it at 90, right? These will all be radii of the circle, right?
Yes.
Yes. I can't. We gotta go get our nails done together or something.
Right.
So we can
Right now?
move here right now. Right. Yeah, you really want me to do the secret thing. All right. Here we go.
Yeah. Where'd you get your gun?
Yeah, we're having a Monday off for a Manny and Petty day. All right, so here we go.
Horrible.
Let's talk basics. SUT. This angle right here. Whole angle's 34. Now they told you that we've got angle bisectors here. So PU is an angle bisector of SUT. So what does that mean about angle 1 and angle 2?
Check it out.
I'll say it again. SUT is 34. PU is an angle bisector, so it bisects SUT. So that means angle 2 and angle 1, what are they going to be?
I don't know, I just made that up. Don't quote me on
I need some more color pens.
That's right. If you want, borrow. I got a bunch right here. These are all for you guys.
the whole
This
thing.
is the student
throw
fund.
it at him. The whole can.
A
Oh.
The
lot of
whole
excitement
table.
today.
The
All right.
desk.
I'll say it again. SUT is the whole angle. That's the orange angle, right? And it's 34. If PU is an angle bisector, what does that mean about angle 1 and angle 2? Well, angle bisector means what?
It's to cut in half.
Cut the angle in half, right?
She does that.
So the whole angle is 34. So what do we know about angle 1 and angle 2?
It's 34 cut in half.
Cut 34 cut in half, 34 over 2, right?
Wow.
Now what's 34 divided by 2? Better question, what's 30 divided by 2?
15.
15. What's 4 divided by 2?
2.
So 34 divided by 2 is going to be what?
12. 32.
Try again. What's 30 divided by 2?
15.
15. What's 4 divided by 2?
17. 2.
2. So 34 divided by 2 must be 17. 15 plus 2, right? These are each 17.
Life is crazy.
So we're going to write measure of angle Juan is 17 degrees. Cool.
Angle 2 or no?
Yeah, angle 2 would be 2. They don't care about angle 2, right? Turns out both will be the same. That's angle bisector, right?
Why is it negative 2 degrees in here? Wowie.
All right. SQR
Huh?
is what we're trying to look for, right? We're trying to look for the whole angle, right? But they told us angle 2, this angle right here, let me include it. Angle 2, that angle, this bit, that's 13. Now, if PQ is an angle bisector, what does that tell us about angle 1? What does it tell us about angle 1? Angle 1 is also 13. So what's the orange angle going to be?
Oh, that would make
26, right?
sense.
SQR, measure 26, right? I'll hang on to it. If you can come into homeroom, that'd be great. Did I write you a pass for that too, or no? Okay.
I'm sick.
So maybe I should have
I'll leave it right here.
since the beginning of the year because you're going to be good at it.
So does that make sense? Right? If we know half of the angle, we just double it, we get the whole thing, right?
Yeah.
Now, how do we know that those two angles are half? Because I can draw an angle, right? and I could cut it. How do I know those pieces are half and half? I don't, right? Unless they tell you that PQ is an angle bisector, right? If I told you this line bisects this angle, then I know I got half and half, right? If I don't tell you it's an angle bisector, well, maybe it's like, I don't know, 10 and 40. I don't know. Could be, right? But if I tell you it's a bisector, it's got to cut both in half, so they're both going to be the same, right? So because we know these are angle bisectors, it's not too bad, right? All right, here we go. 3. Bum, bum, bum. So D to P is an angle bisector. It cuts this angle in half. And PF is also an angle bisector, so it cuts this angle in half. So we have two angle bisectors intersecting. Shelton, if two angle bisectors intersect, what's the point that they intersect at? That's the incenter. So P is the incenter, right?
Like this, like.
And the incenter is the center of what?
Circle is inside the triangle.
We have to stand. Yeah.
Australia.
No choice. That's right. Australian power. We need to get you like an Australian flag to wave. Australia
Wait, so
strong.
what's the incenter again?
Hashtag Australia. What?
What's the incenter?
The incenter is the center of the circle inside the triangle. So if you look, there's the circle inside the triangle, right? Now, if we go out from the center to the opposite side, right, and make sure it hits at 90, then these are radii, which means they're all equal. That's kind of useful. Okay, so what question are they even asking us? Well, they're asking us that, they're saying that PT is 3. So this side right here, PT, let me zoom in so you can see it even more. They're saying that PT is 3. And they want us to find PU. Well, if all those are radii, right, the radius of the circle, right? It's always the same no matter where you go, right? So they're all 3.
Oh, that's pretty.
That makes sense? Since that's the incenter, I know that all those lines are radii. And radii are all congruent, right? If I've got a circle, the distance from the center to the outside is the same no matter where you go. That's what makes it a circle. If it's not the same, you got an oval, right? 4. Well, FP is an angle bisector, they said, and GP is an angle bisector, and HP is an angle bisector. They cut these angles in half, right? So where they intersect at P is going to be the incenter, right?
I have 4 pages. I was a bit confused.
So P has to be the incenter, which tells us what about PX, PW, and PV?
They're
The radii, right, of the internal circle. So they want to know about PV.
Let's go.
Yeah. They want to know about PV. They said PW. Well, that's 7. So what's PV going to be? Also 7. Now you're feeling all cozy and great about this because it seems easy, but what happens when I give you some random triangles, right? And some are in center, some are circumcenter, some are other things, right? You've got to know the difference. So more important than getting the answer here is knowing why we got it. How do I know that P is the incenter and not some other center? How do I know that P is the incenter and not some other center?
Because it's the circle inside the triangle.
The meeting point of the what?
I just said meeting point.
Okay. How do we know P is the incenter and not like a
You're
circumcenter?
talking about 4.
Huh?
I thought you were talking about 3.
I wish
Cool.
that I had.
I just said it's the
Ladies, I need you back here.
meeting point of all lines.
What, not all lines, certain lines. How do we know P has to be the incenter? Tucker.
Because the perpendicular lines are radii. Yeah. No,
Yeah, that does work. Here, how about I ask this question? Let me give you a picture. That's a triangle.
it's quite fun, Charlie.
I only know that this point right here, P, is the incenter if these lines are what kind of lines?
Radii.
Nope, not radii.
Oh.
You get confused. I'm not talking about those, I'm talking about these kinds. Angle bisectors. I only know that this guy is the incenter if those are angle bisectors. Do you smell when I'm stepping in there? Maddie's, I need you back, please. It's cool. I only know that P is the incenter if it's the intersection of the angle bisectors. If I've just got some random lines, right? I don't know that that is the incenter, right? They're just random lines intersecting. I can draw random lines all day, right? I know P is the incenter because it's the intersection of the angle bisectors. How do I know these are angle bisectors? Those two lines. Excuse me.
Wait, okay, so the lines
Oh, those.
around the circle is what it equals? Or,
So the lines, like let's go back to 3. These lines that go to from the center to the circle, right, to the opposite side, those are radii, right? Those are all going to be equal. That's true.
and that's what, like, for number 5.
Not yet. Don't worry about 5. Don't worry about 5. Okay. What we're saying is, how do we know that P is the incenter? How do I know that that's the center of a circle that fits inside the triangle? Now I drew one in, but if I hadn't drawn it, how do I know that that's the incenter? It doesn't look like it, but again, let's get you seeing. How do I know that is the incenter? The incenter is always what? The intersection of what? It has to do with the circle. How do we find the incenter? What kind of lines are these?
Angle bisectors.
Angle bisectors. P is always at the intersection of angle bisectors. So if I have a triangle, right, and I've got some lines going, I don't know that that is the incenter. I don't. But if I know those lines are angle bisectors, right, then I do know it is, right? Do you understand that? That's more important than just getting the answer. Because eventually, all these won't be angle bisectors. Some of these will be incenters, some of them will be circumcenters, some of them will be medicenters or centroids, right? So you need to know the difference. This is an example. I know that P here is the incenter. Why? Because they told me from the beginning that these are angle bisectors. So because I know that these lines are bisecting their angles, right? I know that P must be the incenter. And if P is the incenter, that means the distance from P to the opposite side is going to be the radius, okay? Which means all those will be equal. This is only true if P is the incenter. If it's some other random point, that's not going to happen, right? We know P is the incenter because it's the intersection of the angle bisectors, right? That's the key. So if we look here, PW, PX equals 5. Well, PW and PX should be the same. How do I know that PW and PX are the same length? Because P is the incenter. And the distance from the incenter to the opposite side is always the same. It's always radius, right? Again, if I didn't know that P was the incenter, I couldn't do that. But I know it's the incenter because it's the intersection of the angle bisectors. So if PX is 5, PW is 5. Again, finding the answer is easy because you're seeing a pattern, but I don't want you to think all triangles are like that. It's only when we have angle bisectors. So 6.
Where do you 7?
We'll get there. So again, they told us in the instructions that all those lines are angle bisectors, right? And so those are angle bisectors. What does P have to be? If all those are angle bisectors, what does P have to be?
8. 4.
I like your enthusiasm. I'm not asking about the answer. If that, and that are angle bisectors, and they are, see how they're marked? Right? It cuts that angle into 2 equal pieces, cuts this guy into 2 equal, cuts this guy into 2 equal pieces. That means these lines right here are angle bisectors, right? And they all intersect here. The intersection of the angle bisectors is what? What do we call that center? Maddie, what do we call that center? Sheldon? The incenter. And we know the incenter is the center of a circle inside, right? Which means these are radii. So they're all the same. So if PC is 8, then PD must also be 8. Right? But that's only true if P is the incenter. If it's not the incenter, then that's not what's going to happen. So for instance, let's talk. Again, I'm more concerned with this than just getting down the answers. I don't think the answers are too hard in this worksheet. So let me give you a triangle, random triangle. Okay. There we go. is P the incenter? No, because P is supposed to be where the angle bisectors are. These lines aren't angle bisectors. What kind of lines are those? Medians, vertex to midpoint. So that's not the incenter. What is it? What's the center of the medians? It's the one we learned first. Centroid, right? Center of mass. So if I were to draw a line from here to here, and draw a line from here to here, and a line from here to here, yeah, those are all 90-degree lines, and it looks a lot like this, doesn't it? But we don't know those are all equal, because that isn't the center of the circle in the inside, is it? Right? It's the median. The median is not the center of the circle, the incenter is. So we can't say they're all equal. The only reason we can say that all of these guys are equal is because P is the incenter. How do we know P is the incenter? Because it's the center of the angle bisectors, right? The intersection of the angle bisectors. Let's look at 7. It says PY is 2 and HP is 3. So PY is 2 and HP is 3. Find HY. Ooh. You guys see this? So that's 2. All these are 2, right? All those guys are 2 because they're radii.
Whoa.
Is HP a radii? No, it's not, right? That's our angle bisector. Okay. They told us HP was 3. So what they're asking about is this triangle right here. Where do you see that triangle right there, colored in? So what they're asking about is this. I'm going to draw it over here. Looks like P is up here, Y is over here, and H is over here. And they told us that PH is 3, and PY is 2. We want to know what HY is. Well, right now there's no way to solve that. It could be anything, right? But if you notice, isn't PY a 90-degree angle? Right? So if that's 90, shouldn't this also be 90 in here? Linear pair, right? So that must be 90. So what kind of triangle are we looking at? Right triangle, perpendicular triangle. I'll take that. But yeah, right triangle, right? What do we know about right triangles and their sides? Do we have something that helps us find the other sides of a right triangle? Don't fail me now. It's been a semester. Now you got to think outside the box. It's not something we've done lately. P-tag, right? A squared plus B squared equals C squared. Now C always has to be what side? The big one, hypotenuse, right? So that has to be C. Let's make this one B, and then A is what we're looking for, okay? So we're looking for A, B is 2, and C must be 3. So this is a harder problem than what we've been doing, right? PY is 2, PH is 3. We got to find the other side. Now we know that's 90 degrees because this is a radius, and radii always hit at 90. Okay. So we've got a squared plus 4 equals 9. What do I do now to get a squared on its own?
Subtract 4.
Yeah, subtract 4 to both sides. So a squared must be 5. How do I get rid of the square? Square root, right? So if I root both sides, I get regular a on its own because that gets rid of the square. And then I root this side, root 5. That's the answer. When you do p-thag, you're going to get a lot of gross numbers, right? What?
So how did you get that 5?
Well, we had a squared equals 5, right? I did that by subtracting 4. That's what Doc said. And then I rooted both sides. Root gets rid of the square. We get root 5. When you do p-thag, you're going to get a lot of weird roots a lot of the time. Right? But sometimes they'll be nice roots, like root 25 would be a nice root. What's the root of 25?
Wait, that's not even
2.24.
5, right? So hy should be root 5, right? what they give you as the answer for 7.
2.24.
Yep, and root 5 is approximately 2.24. You try 8 on your own. We're going to go back and do the rest tomorrow. I urge you to not just think, oh, look, they're all incenters. Make sure that they are, right? Read the instructions, see what's going on there. Because eventually we're going to throw them all together, and you're going to have to pick them out, right? The incenter is always the intersection of what lines? Angle bisectors. Yep. If you got angle bisectors, you've got an incenter. If you don't have angle bisectors, you must have something else. Cool. We're going to keep them all separate this week, and then next week we're going to throw them all together. So make sure you are ready to roll. Yeah, add what you are upset about. You're not upset about anything? That's great.
No, just kidding. Get out of my face.
Some lady threw a whole cup of salsa at me because there was tomato. I think Jenna wrote that. I think she had a bad experience at Happy Meals the other night. Waitressing.
I would think people would know that they were planning this also.